Okay, so today's lesson is lesson 43 on page 225 in your book, talking about equivalent division problems, finding unknowns in fraction and decimal problems. And all we're trying to do, guys, is show a relationship between big numbers and how we can make those numbers smaller by using a number that goes into all of our numbers evenly. And if it doesn't go in evenly, then it's not going to work. And we start off on page 225. The new concept, it shows us, it says the following two division problems have the same quotient. We call them equivalent division problems. Which problem seems easier to perform mentally? And so what they're giving us here is this situation. Oh, hang on, let me make this screen black. I like working with the black screen better. And let me make sure it's going to stay black. No, it's not. There we go. All right. Now I'll get a color that I like. Let's start with that color. All right. So here's our problems. We have 700 divided by 14, and then we're also looking at 350 divided by 7. Which one of those problems is easier to do in your head, obviously? Ben? A? No, it's not. No, it is not. 700 is not easier to divide by 14 than 350 is by 7. Why would you say that? Huh? 7 is half of 14? So 7 would be easier then, the smaller number. Just a smaller number to divide. That's like saying that 2,420 divided by, I don't know, divided by 40 would be easier than half of that, which would be what, 1210 divided by 10. I mean, come on. Anytime you're making a number smaller, it's easier to do in your head. That's why it's called mental math. So unless you're a math whiz, and you know, Ben, you're pretty good at math, so I mean, I'm not going to doubt that you are good in math. You have a good grade in the class. But even for good math students, typically the smaller the number, the easier they are to work with. So what most of you would find, maybe everybody except Ben, is that 350 divided by 7 is easier to do in your head because everybody knows that you know, this problem here means what times 7 gives me 350. Just like Ben has to say to himself, what times 14 gives me 700? Well, I can get rid of this 0 and say 7 times 5 is 35 and add my 0 back and get 50. Right? I wouldn't know, and I'm probably a little bit better in math than anybody in the classroom here. I wouldn't know off the top of my head without doing some calculating that 50 is instantly the answer to this question. You know, I can look at this and instantly know, because I know my 7 times tables. I don't know my 14 times tables. Ben, what's 14 times 17? So you don't know them either. So, but well, but if I asked you what's 7 times 5, you know, just like that. So that kind of shows me that even you, if you did it this way, you would find that this way is actually easier to divide because few of us know our 14 times table, but all of us know our 7s times table. So the point the book's trying to make is that the smaller the number, the easier they are to work with. Would you agree with that? The smaller number is easier to work with when you're dividing, especially if you're dividing. So the point is that when you have 700 divided by 14, or if you have 350 divided by 7, the idea is to build some kind of equivalency between the numbers in this bigger problem. And we do that by dividing. We take this number here and we divide it by 2, and we all know that half of 700 is 350, and half of 14 is 7, and that's how we got this number here. But we're not even done with that. We could take this and divide this by 7, and we're going to get 50 divided by 1, and this cancels out because 7 divided by 7 is 1, obviously, but 50 divided by 1 is going to be 50. So we know that for all these equations, for this one here, for this equation right here, for this equation right here, and for this equation right here, all the answers are going to be the same. All the answers are going to be 50. The quotient for all three of these are 50, which means that this big number, 700 divided by 14, is one way of coming up to the answer of 50, but so is 350 divided by 7. That's another way where the answer is going to be 50, and of course 50 divided by 1 is going to be 50, so they're all equivalent, and you take this really big number and find out how to get it to a smaller workable number by dividing it by the same number equally. Do you understand that? We divided the 2 by the 700 and the 14. We divided the 350 and the 7 by 7. Now look at, guys, we could have done this. We could have started off with 700 divided by 14 and done what? We could have divided it by 7 right from the beginning, couldn't we have? And then we would have gotten 700 divided by 7 is 100, divided by 14 divided by 7 is 2. And that still equals what? 50. Which means if we'd have done, like Ben was saying in the very beginning, if we take 700 and divide it by 14, if you're good with math in your head, you know instantly the answer is 50. But like I said before, very few of us know our 14's times tables, where we can say, oh yeah, 14 times 5 is 70. Therefore, I add my 0, I get 50. Very few of us know our 14's times tables. It's just a number we don't normally memorize in school. And we don't normally have to, because we have calculators for that. Okay, so that's all we're doing there with that new concept. That takes us over into our first example on page 226. I'm going to change colors. That pink doesn't really show up very well with the lights on. So here we go. Now we have this problem here. It says form an equivalent division problem for the division below, then calculate the quotient. So we have 1200 divided by 16. It wants us to form an equivalent division problem. So Peter, how would I do that? Then I can't see unless I had my thing. Hang on. It's easier with the lights on. Unless you're anybody taking notes. Well, if you're taking notes, you don't want the lights off. If you're not taking notes, you can turn the lights off, and I can use my whatever you want to do. If somebody needs the lights on, by all means, leave the lights on. Okay, hang on just a second. Don't know if I had a flash. I got this. This will work, bud. All right, so here we go. We have this situation. We have 1200 divided by 16, and it wants us to find an equivalent division problem for this. So how would I go about doing that? I want to find the number that I can divide both numbers by evenly. What number would work? It's got to be a number that will go into 16. It's got to be a number 16 or less, right? I don't know my 16 times table, so I don't know if 16 times something will give me 1200. Mason? I can divide by 4. Okay, so let's do that. So I'm going to write this over here. Now, what's 1200 divided by 4? 300. And then what's 16 divided by 4? 4. So now I'm saying that 1200 divided by 16 is equal to the answer of 300 divided by 4 is what I'm saying, right? Can I reduce that down a little bit? Can I divide that by something? By 2? Okay. And what's half of 300? So I have 150 divided by half of 4. Okay. Am I done? Can I divide that down by something else? Yeah, I can, can't I? I can divide it by 2, and I get half of 150 is 75, right? And half of 2 is 1. So I'm done. I can't divide anymore. So I know that my answer, when I'm done dividing down, guys, when I get to this point right here, then this answer, 75, should be the quotient to this problem, and it should also be the quotient to this problem. and we know it's going to be the quotient to this problem because we just got down there from there. So we can take a couple things we can do. We can actually do the division of 1200 divided by 16, or I could take 75, which is my answer. I can multiply it by 16, and it should give me what? 1200, right? So let's see, 6 times 5 is 30, carry the 3. 7 times 6 is 42, plus 3 is 45. 1 times 5 is 5. 1 times 7 is 7. I get a 0, I get a 0, I carry my 1, and I get a 12. Sure enough, it's 1200. So this right here is the same thing as this, which is the same answer as this. So these are equivalent division problems. Do you understand that? Everybody okay with that? Okay, if you're not, raise your hand or say something. All right, we're going to move on. As soon as I get my thing where I can see what I'm doing. Okay, the next one is going to be this. It wants us to form an equivalent division problem for the division problem below, then calculate the quotient. And now we're going to have 7 1/2 divided by 2 1/2. Now look at, instead of doing this, trying to divide this by some kind of number, whatever that number might be, who wants to divide mixed numbers? I certainly don't. I mean, that's just a lot of work, right? So rather than do that, what we could do, let me erase all this here, is let's multiply it. Let's multiply it by something. So I'm going to take 7 1/2. I'm going to multiply it by something. I'm going to take 2 1/2. I'm going to multiply it by something. And whatever that something is, guys, it has to be the same number. So let me just start by doubling 7 1/2 and 2 1/2, right? What's 7 1/2 doubled? What does that equal? 15, okay. And then what's 2 1/2 doubled? 5. Okay, so now I replace this 7 1/2 becomes a 15. And I'm going to divide that by the 2 1/2 was changed to a 5. So what's 15 divided by 5? 3, right? So the question, now another way I can do this is I can make this, I can do it this way here, the way that I did it, right? Or I could make this a mixed number and say that 7 times 2 is 14 plus 1 is 15, so I have 15 halves, and then I have 5 halves. And if I wanted to divide this by, I'm not sure this would help. If I was doing a division problem and I wanted to divide this by 1/2, I could, but you know, when I divide by 1/2, I multiply by the reciprocal, so it's basically 15 halves times 2 over 1, and it's 5 halves times 2 over 1. And what does that give me? That gives me 30 over 2. That gives me 10 over 2. This reduces down to 15. This reduces down to 5. My same two answers, right? So either way, I get the same thing. I think it's easier just to multiply by 2 in the beginning, like we did right here, and get these two numbers, which are replaced. Replace that number with this, and this one here gets replaced with that, which is what we did right over here, and 15 divided by 5 equals 3. In equivalency, we're just saying that by multiplying by 2 and making 7 1/2 a 15 and 2 1/2 a 5, because we multiplied by the same number, we did not change the value of what's happening in these problems. Does that make sense? Everybody okay with that? Any questions with that? Okay. I'm going to erase that, and we'll go to our next problem. This is example 3 on page 227 in your book. It wants us to solve for this. It says solve for d minus 5. D minus 5 equals 3.2. Now, you guys probably know that to do this problem, the easy way, the mental way in your head, is to say that we have to have a number here for d, and it's got to be a big number, right? because we're subtracting 5 from it to give us something else. So we know our number's got to be big. You know that when you're subtracting over here, if you just add these two numbers together, you'll get what you need there, right? So you can say, well, 5 plus 3.2 is 8.2. So D must be equal to 8.2. And so we put 8.2 in there for D minus 5, and sure enough, what is the answer? It's 3.2, and we solve for it. Piece of cake, right? Let me show you the algebraic way to do that for next year and for the years to come. And we've already done these before, so it shouldn't be a surprise to you. Take D minus 5 equals 3.2, and now we have to solve for D. And when we solve for D, we have to get D by itself. And we do that by adding 5 to both sides. Because what you do to one side of this equation with the equal sign, you have to do to the other. So when I subtract 5 from 5, I get 0, right? That leaves me with D equals, and 5.5 is actually 5.0, right? So 3.2 plus 5.0 is 8.2, and there's my answer. My answer is just what it was when I did it the other way. Everybody see that? Not too bad, right? Any problems? Any questions? Going once, going twice. All right, we'll clear the screen and go to our next one. You guys are doing great, by the way. 2 more examples. They want us to solve, and let me get my light on here so I can see. Solve F, as in Frank, plus 1/5 equals 4/5. That's our problem. Now you guys know, without doing anything on paper, you can, in your head, you can say what plus 1/5 equals 4/5, and all you know the answer is what? 3/5. 3/5 plus 1/5 equals 4/5, because you know when you're adding fractions, as long as the denominator is the same, you're good. You just bring it over with you in your answer, right? You don't add it, you don't multiply it, you don't subtract it. If when you're adding or subtracting fractions and the denominators are equal, they're the same number, you just bring that to your answer. All you're doing is what I call the kindergarten math. You're saying 3 plus 1 equals 4, and your answer is 4/5. Let me show you the algebraic way to do this. F plus 1/5 equals 4/5. Okay, we have this imaginary line here between our equal sign. We have part of the problem over here, we have part of the problem over here, and we're saying whatever's over here has to equal whatever's over here in our final answer. Okay, so we do that. We have to get F by itself. To get F by itself, we have to subtract 1/5. Everybody understand why? Okay, and if I subtract 1/5 on that side of the equation, I have to subtract 1/5 on this side of the equation. When I do this, this cancels out, so I'm left with F. I bring my equal sign down, and my denominator is 5, so I leave that as a 5. I don't have to change it. 4 minus 1 is 3. There's my answer. 3/5. Okay, so 3/5 solve for F over here, and F over here we said was 3/5. Okay, any problems with that? We okay? Give me a verbal. I can't see you. We okay? Yes. Okay. All right, great. All right, guys, we have one more to go, and this is solving for 3/5 n equals 1. Okay, in this problem, 2 numbers are multiplied, and the product is 1. That's what's happening here. This can only happen, guys, when the 2 numbers, the 2 factors are reciprocals. Okay, so we have to find the reciprocal for the known factor of 3/5, and by switching the terms of 3/5 gives us the fraction 5/3. That's the reciprocal, right? And you know that. So we check our answer by substituting 5/3 into the original equation for n. So we say that if 3/5 n equals 1, then we could say 3/5 times n being 5/3 should equal 1. And let me get my marker and scroll up here. Okay, so when I do this, I get 5 times 3 is 15 over 5 times 3 is 15 is equal to 1. And obviously 15 over 15 is 1, and 1 equals 1. Everybody see that? Not too difficult, is it, guys? All right. Are there any questions? No questions. All right. Well, we're done with today's lesson. I'm going to turn the lights on in a minute. Before I do, I'm going to record this information for you that today's homework is practice set A through F on page 228. And then you're going to do the written practice on page 229 and 230, 1 through 30, all of them, unless you're exempt. Then you can do the odd or the even. All right?